falling stone takes 0.31 seconds to travel past a window 2.2 meters tall. From what height above the top of the window did the stone fall? So, if we start our imaginary stopwatch as the stone passes the top of the window, then this is what we have. But the question asks for this x. We'll assume that downwards is positive, since this makes it simpler. The acceleration is due to gravity, and since we define downwards as positive, it's 9.8 meters per second squared. X is 2.2 meters and t is 0.31 seconds. But it's important to note these two values are assuming that the origin, or x0, is at the top of the window. But in order to calculate where it was dropped from, it's probably easiest to use a different origin. So we're essentially setting up two mathematical models here, the blue with its origin at the top of the window, and the green with its origin at the drop point. Since it's the green model which can actually give us our answer, let's see what we have there first. Obviously, the acceleration is the same, we want x, and we don't care about t. And since it's dropped, we know that the green v0 is 0. So do we have a formula which can give us what we need? Unfortunately not, but this formula could if we had v, its velocity at the end of the time we're modelling in green. But that is the velocity at the beginning of the time modelled by the blue equations, so we might call it blue v0. And because in this blue model the stone is at the origin at t equals 0, blue x0 is also 0. Here's a more common simplified version of this formula, and then we can substitute, rearrange, and solve for v0. This gives us our final velocity in the green model, so now we can use this formula, commonly simplified to this, and as we said before, v0 is 0 because it's dropped from this point. Then we can substitute in our numbers, rearrange, and solve for x. The original question states values to 2 significant digits, so that's how we should round our final answer. So it looks like the stone was probably dropped from this window, not the one above.